Enjoy. This afternoon, I'm going to talk to you about accessibility, and specifically the problems we can cause as developers when we're trying really hard to get accessibility right, when we're doing everything we can to make accessibility happen. It's sometimes possible to cause a few problems along the way without really realizing that you're doing it. If you want to get hold of me at any time, today or in the future, my contact details in various places are on the screen. Feel free to ping me with questions or queries or things you think I might be able to help with. I'd be happy to. So to do this today, I'm going to use one of my favorite quotes from a classic 1960s film starring Michael Caine called The Italian Job. And this is the bit of the film in question.
5, 4, 3, 2, 1, go. You're only supposed to blow the bloody doors off.
And this is very much what it's like with two technologies in particular, JavaScript and ARIA. We can set out to just blow the doors off something, do exactly the right thing with exactly the right amount of technology. But somewhere along the way, it turns out it's remarkably easy to blow the entire thing up completely by accident. Hopefully, by the end of this talk, I'll put you in a position where you can avoid some of the more common problems with JavaScript and ARIA. To do it, I'm going to focus on a particular piece of technology called a screen reader. If you're not familiar with it, it's a piece of software that translates what most people see on screen into synthetic speech. It's used by people like myself who are blind because we can't see what's on the screen or the monitor, and so we need to access it through audio means instead of visual. There are 4 key players in the screen reader market that you're likely to come across in your audiences for the products that you're building. There's VoiceOver, which is developed by Apple, and it comes free and integrated on all Apple platforms, whether they're touchscreen or keyboard devices. There is Narrator, which comes with Windows 10 and is the newest addition to the screen reader marketplace in many respects, but it's a very capable screen reader. Then 2 others on Windows. We have the JAWS screen reader, which is perhaps one of the most long-standing screen readers that's been available on the market. And also NVDA, which is a free open source technology. JAWS and NVDA are very similar in capability. Their primary difference is that JAWS costs the earth. NVDA is free because it's open source. So there are 3 good screen readers to test with if you are interested. The VoiceOver on the Apple devices, or NVDA or Narrator on Windows devices. If you can get hold of a JAWS license and test with that, so much the better. But those 3 are the place to start if you're really curious about how stuff works. Screen readers, as I say, translate things into on-screen content into audio. So, for example, this is how it sounds listening to a piece of text on a web page.
ARIA Accessible Rich Internet Applications is a suite of specifications from the W3C. Knowing which specification has the information you need isn't always obvious, so this put briefly.
So loud is the first characteristic, obviously, but that's just a screen reader command that says to it, please just read this paragraph of text. And to identify that paragraph, it's using the HTML-P element. Nothing more complicated than that. It will also work with other kinds of HTML element. So, for example, screen readers have lots of shortcut keys that they can use to navigate between things like headings, like this.
Tink Heading Level 1. Quick Guide to the ARIA Specifications Heading Level 2 link. Using the ARIA Current Attribute Heading Level 2 link.
And most screen readers have many shortcuts for navigating. So H commonly will navigate between headings, L for lists, I for list items, T for tables, G for graphics. Pretty much every key on a standard keyboard is used by a screen reader, particularly Windows screen readers, to help people navigate quickly through content. It used to be, maybe 10, 15 years ago, that a screen reader user would have to start listening to content at the top of the page and read it all the way down to the bottom without stopping. There was no understanding, really, of HTML elements at all, but that's very much changed. So HTML elements play a key role in the way screen reader users navigate around content. They're also quite capable of interacting with forms, of course, another necessary part of the web. Now, you might be thinking, if all those keys, the H, L, T, G keys, are used for navigating, what happens when we want to type into a form field like a text field? Or what happens if we want to use a select box and use the down arrows to select one of the options in there instead of doing what a screen reader would normally do and reading the next line of text?
Tab, favorite drink, edit. TEQUILA. Tab, which type, combo box, blanco. Reposado. Joven.
And the answer is that when a screen reader focuses on a form field, it basically says, okay, I'm not going to bother paying attention to the keystrokes. I'm just going to let the browser have access to those keystrokes, exactly the same way that a browser would have access to them if the screen reader wasn't there at all in the first place. We have something called the keyboard intercept chain in terms of screen readers, and it behaves a little bit differently cross-platform. If you use a Mac OS device, the screen reader there, VoiceOver, will ignore any keystrokes. They go straight through to the browser, and if the browser doesn't want to use them, either for an application shortcut or because there's JavaScript in the page that needs them, it'll then let the screen reader do its thing with that particular keystroke. This is actually a really sensible model. Windows screen readers do it completely differently, unfortunately. In the case of Windows screen readers, they grab the keystroke first, and if they want to use that keystroke, they go ahead and do it. And only if the screen reader doesn't want to use that keystroke does it get passed back through to the browser and the website and the JavaScript. So this can cause a bit of a problem in some cases. The reason Windows screen readers do this is because they create something called the virtual buffer. When the DOM gets loaded into the browser, they team it up with a whole bunch of other information that the browser makes available, and they create a virtual copy of the web page in the browser. This is purely an efficiency move. We'll see later how screen readers get information out of the browser. And for various historical reasons, what they prefer to do is grab an entire copy of the page that they can then query in their own processes, rather than making kind of repeated queries back to the browser, which has proved to be somewhat inefficient over the years. So when a screen reader, particularly in Windows, happens, is they focus on a form field. They ignore that virtual buffer. They just ignore the copy of the page and instead just go straight back to interacting with the version of the page that exists in the browser, the page that you are all familiar with as developers. And this keyboard intercept is really important because it can scramble things for Windows screen reader users in particular. So, for example, the Twitter website very helpfully uses JavaScript to make some keyboard shortcuts available. There's a whole bunch of them. You can use them for moving between the next tweet and the previous tweet, to reload new tweets, to reply or direct message someone from an existing tweet. They're a really good usability step. They help a lot of people. But for Windows screen readers, the keyboard intercept gets in the way. So if we take a look at a Windows screen reader using, say, the J key, which is the one you'd normally use for moving to the next tweet, this is what happens in one particular screen reader.
Jump to line dialog. Enter line number 1 to 954. Edit.
In that screen reader, the J key is used for opening a navigational dialog that lets you move to a particular line of code within the web page. It's actually an entirely redundant piece of functionality from a screen reader user's point of view, because unless you happen to know that there are X numbers of lines of code in the page and what line of code the thing you're looking for is on, there's almost no reason for you to ever want to navigate to it. But in this particular instance, that functionality exists, but it effectively stops the JavaScript shortcut from working on the Twitter website. The solution is actually pretty simple. What you need to do is just when you provide JavaScript shortcuts, keep doing it because it's really useful for a lot of people, particularly keyboard users who don't use screen readers, but just make sure that it's an enhancement to the application, that it's not the primary or only way of doing something. Make sure there's a physical fallback on the page, maybe a button to load more tweets or buttons to move between the next and previous thing, whatever seems logical, but whatever that physical fallback is, make sure it's usable in its own right as well. So how does this all work under the hood? What's the browser actually up to? Before the screen reader gets even close to this, what's going on in terms of the code and the way the browser manipulates it? The answer actually lies in the operating system. If you look at any typical UI component in the operating system level, be it a checkbox like the one from Windows 10 that we've got up on screen at the moment, or any other button, menu, screen, window, there is accessibility information available about that particular object. So this particular checkbox, it has a role of checkbox, that's what it is, what its role in life is. It has an accessible name that's provided by the visible label, in this case it's bold, and there is information available about the state of the checkbox. It can be focused on, it is focused at the moment, and it's also in a checked state. And all that information is available about that particular object. It's the same if this checkbox appeared on Mac OS or Linux or on one of the touchscreen OSs as well. On all platforms, this information is available. And the way screen readers and other assistive technologies get at that information is using platform accessibility APIs. Again, they're available on all platforms. Some have more than one. Microsoft uses 3 different accessibility APIs. Linux has a couple, although they tend to work together as one. Mac and iOS both have an accessibility API, as does Android. And an assistive technology like a screen reader will use this API to query an object in the operating system and basically say, hey, what are you? What do you do? What state are you in? Because that might be obvious to someone who's looking at it visually, but to someone using a screen reader, of course, it's much more difficult to tell if something's checked or unchecked, or even that it's a checkbox in the first place. It's important to say at this point that this is not a JavaScript API. It's only usable by assistive technologies like screen readers. So this is a fairly sort of closed off set of APIs for the moment, but there is a possible change on the horizon, which I'll mention a bit more about later. The interesting thing is that if we were to try and recreate that same software component on, in a web page, so this checkbox, just using an input type of checkbox with a checked attribute and an associated label to provide the text, the visible text label, we'd find out that the accessibility information is exactly the same. It's got a role of checkbox, an accessible name of bold, and it's got the same state information about it being focused and checked in the current state. And these relationships between common application or software interface components and the things we create typically in the browser are all documented by the W3C. So if you use an HTML element or even an SVG element, you can go and find out what it maps to, what its accessibility information should be in the browser. There's one thing to bear in mind about this is what accessibility supported means in a browser. So if a browser supports an element of any kind, that means it presents itself, it renders on screen in a certain fashion. If it's an interactive set of elements, say perhaps details and summary, then there is a certain behavior that the browser makes available about those elements as well. But there is a next step. A browser also needs to accessibility support an element, and the two are not necessarily the same thing. It's also, of course, worth bearing in mind that just because a browser supports and accessibility supports an element, it doesn't mean that a screen reader or any other assistive technology is going to make use of that information. But if you're curious about how well different browsers do in terms of accessibility supporting HTML5 elements, html5accessibility.com is a really great resource. It has ratings for all the different browsers and lots of tables with useful information in. So when the browser loads a document, you know, of course, that it creates the document object model, the DOM tree. And this is a hierarchical structure that contains many nodes representing the content and information in the browser. The browser also creates an accessibility tree. So as it takes information from the DOM and visually represents it in the browser window, it also takes information from the DOM and creates an accessibility tree. This tree, too, is hierarchical, and it contains nodes that contain lots of accessibility information. So for any particular element or node in the accessibility tree, you'll find out its role, its state, its accessible name, and if it has one, a longer description known as accessible description. And the assistive technologies like screen readers will use the platform accessibility APIs to query this information in the browser in exactly the same way they query the operating system or applications for information about software components. So this is the basic rule of thumb. What happens? The browser creates the DOM. It then creates the accessibility tree. If the DOM gets updated for any reason, because you're using framework that's updated part of the DOM, there's some scripted interaction that's caused one or more things to update, or it's a user interaction that has done the same. The DOM gets rebuilt. That triggers the browser to rebuild the accessibility tree. That fires an event that assistive technologies listen out for, and when they hear that something has changed in the accessibility tree, they know to go and get that information and make it available to someone using a screen reader or other assistive technology. So what happens when we're not using native HTML or we're not using SVG? What happens when we're creating something from scratch? Web components, custom elements, well, custom widgets that we've been building on the web for years now. They tend to start with divs and spans as their primitive building blocks. The catch with those two particular elements is that they really don't convey any accessibility information at all. Assistive technologies don't pick up on a role for a span or a div. There's no state information about them. They're not focusable, for example. You can't really do anything with a div or a span, except to use it as a styling hook or as the building block for some new functionality. And the answer lies in a technology called ARIA, Accessible Rich Internet Applications, to give it its full title. And it's a set of attributes that you can apply to HTML or SVG to polyfill that accessibility information that screen readers need. Screen readers are really the only assistive technology that use ARIA, which is why they're mostly the focus of this talk. There is one speech recognition tool called Dragon, version 13, that supports a tiny amount of what's available in ARIA. But to all intents and purposes, it's a screen reader solution for accessibility. So it's really important to bear that in mind as you start using it. The first rule of using ARIA is don't use it. If you can use native HTML in particular, you get a lot for free. You get interactive components that are focusable when they need to be. They also have keyboard interaction support, so you can hit a button with a space or an enter key, you can interact with a select, you can use form fields with a keyboard. The browser does all that hard work for you. So where you can, the easiest way to good accessibility is actually to let HTML and the browsers do as much of the work as you possibly can let them get away with. But, of course, that's not always possible. But it really is this simple. So we take this really simple example of just a button. It's just a button element with some text in the middle, really short, really sweet, basic 101 HTML. This is how a screen reader would interact with that particular bit of code.
Tab, tequila button.
So as soon as the screen reader tabs onto it, it gets the visible label, the text read aloud, and it also immediately knows it's a button. And that's all been taken care of because the browser understands what a button element is, and it makes the right accessibility information available to a screen reader. So it's really nice and easy. You just code HTML like you always have done. But there's always a time when you do need to use ARIA. And that's, like I said, when you're using the div and span elements in particular to start building functionality, either because, well, maybe you're using a framework where they've decided it's a better idea to recreate a span into a link because there's something wrong with the anchor thing, well, it happens, or because you're wanting to create something that doesn't really exist in HTML, like a set of sliders, for example. There are lots of reasons why we start building these things from scratch. Not least, of course, as I said, custom elements and web components. If we really want to let our imagination kind of fly on the web and see what new interactions and models we can come up with, we've got to make sure that the accessibility is there in step with it. We've got a long way to go in accessibility terms in that regard, but one of the possibilities is using ARIA. So what happens when we have missing semantics? If we use a span as the building block for a button, we've got a class there that adds button styling, but this is not an interactive element. There is no functionality here. There's nothing except a little span. So this is what happens when you try to use it with a keyboard. Nothing, because you can't focus on a span with a keyboard. The browser would have made a native button focusable, but because it's a span, that's something you have to provide yourself, and this is where the work starts to kick in. A screen reader would make this of that particular fake button.
Tequila.
It'll recognize that there's some text on the page, but it doesn't recognize that it's a button because at the code level, the accessibility level, it's not. It's just a span holding a piece of plain text. It doesn't matter how much it looks like a button or even may function like a button should you click on it. To a screen reader, it's just a piece of text, and there's nothing to tell you that it's something you can interact with. So if there's something important is going to happen when you hit that button, a screen reader user is pretty much just going to miss it entirely. So we can add in some semantics using ARIA. We can add the role attribute to the span and give it a value of button. And this just says in the accessibility tree, treat this span as a button. In the DOM, it stays exactly the same, but now in the accessibility tree, so to a screen reader, this thing is now actually a button. We've also added the tab index with a value of 0 to make this particular element focusable by all keyboard users, not just screen reader users. And so this is the difference.
Tab, tequila button.
So it's exactly the same as though we'd used the HTML button element in the first place. Only this time we had to add in the role, we had to add in the tab index attribute. We also have to add in some extra functionality to make it work with a keyboard as well. The button element, of course, just works with the click event, and it fills in the keyboard support for you. But if we're doing this with missing semantics, we need to fill that in for ourselves. Something else you can do to break things for screen reader users is breaking the native semantics and confusing things. So what happens if we take a button element and give it a role of heading and an ARIA level of 1? So we're going to try and convince a screen reader now that this thing that actually is a button, looks like a button, probably behaves like a button, is, to all intents and purposes, a screen reader, a heading.
Heading level 1 tequila.
So someone comes along with a screen reader, and they come across this thing, and they're told it's a heading level 1, which is very interesting. But it's not functional. There's nothing to indicate that this is actually a button, something they should press a key to get at or to interact with. So we've really confused what's going on from the point of view of a screen reader user. So when you use the role attribute in ARIA, be very, very careful about overwriting the native semantics of HTML. There are times, as we'll see later, when it is a good thing to do. But think about it very, very carefully, because if something looks like a button, it behaves like a button, then generally speaking, you're going to want a screen reader user to know that stuff too. With ARIA, you need to make sure that the keyboard interaction is there. I mentioned this briefly a moment ago. So you have to provide the expected keyboard interaction that the browser would have done if you've been using the native elements in the first place. Sometimes it means you have to provide extra interaction. So a common pattern I come across all the time is somebody starts off with an anchor element, but they've actually styled it to look like a button for various reasons. So to a sighted keyboard user, this thing looks like a button, and they're going to expect keyboard interaction for a button. So we need to add a little bit, because the browser will let you activate a link with the enter key, but not with the space key. If it had been the button element, you could have used either. So we've just got to add a little bit of JavaScript that listens out for the space key and make sure that if someone comes along and they try to activate this particular thing using the space key, it works as they expect it would, because it looks like a button. Sometimes you need to provide all the interaction. So if we'd gone back to our span as the basic building block for our button, then we'd have had to add in the JavaScript to make sure that both the enter and the space keys were in use and listened for, as well as obviously the click handlers to make sure it worked with a mouse. So you can really start to see now how much extra work there is involved in putting in accessibility when you don't let the browser do as much of the hard work as you can. So this is what happens now. When we filled in all the missing semantics using some ARIA, we've added all the keyboard interaction in using JavaScript that's expected. This is pretty much what happens.
Tab, tequila button collapsed. Enter, expanded. Blank. Makes me happy.
You see what we'd have missed if we hadn't had all that accessibility in there? We'd never have known that tequila was so good. But it's serious, though. There might have been accessible help information, accessible through that disclosure widget, or other bits and pieces that, if we hadn't have made this effort, a screen reader user would have been completely oblivious to. And that, of course, is not really a good thing. If you really want to know how to blow the car up for a screen reader user, this is how you do it. There is a role value in ARIA called the application role. And it basically says to the screen reader, stop it. If you put it on the body element, for example, a screen reader will come to the page, and none of their shortcut keys will work. None of their typical ways of navigating through content will work. All they'll have access to is the tab key. So any information on the page that isn't focusable will no longer be accessible to a screen reader user. It's one tiny little attribute, and it will utterly, utterly stop screen reader users in their tracks. It was designed because ARIA originally was supposed to be for polyfilling the accessibility of software components when we wanted to create them on the web. And the thinking is that to do that, we should expect screen readers to switch to the behavior that they normally exhibit in software applications, where typically the tab key and a few others are the ways of navigating around software. It turns out in practice, actually, that this application role has caused more trouble than it's worth. Sadly, it gets a little bit worse than that, because it's not the only role that triggers this particular behavior. There are lots of them. The tab list role, grid, menu and menu bar, and toolbar are just a few of them. What's really extraordinary is that the roles that trigger this behavior in screen reader are not documented anywhere. I keep meaning to do it. I will get around to it because it's really important. We need to know as developers quite how much power we're wielding in terms of screen reader interaction when we use different roles. And these roles are all incredibly important because they really will strip a screen reader of all its capability. So to give you an example, we'll use the tab list role. So this is just a set of tabs. We're repurposing a UL element, and we're giving it a role of tab list. We're doing the same with an anchor link and giving it a role of tab. And this is one of those times where it is OK to override what a native HTML element is supposed to do. The reason is that if someone is using a screen reader where they don't have ARIA support, that doesn't happen very often these days, to be truthful, or if they're in a situation where JavaScript is unavailable to them, so the functionality of the tabs and the tab panels is unavailable to them, we don't want to show a screen reader a set of tabs. We want them to default back to the old HTML, so a list containing some list items. That's also why we've got the role of presentation on the list item element. When the ARIA solution, the JavaScript solution, is enabled, we don't really need to know about the list item. So we set it to have a role of presentation, which basically says, just ignore this, treat it like a presentational element, not something that has a semantic meaning. Of course, if we default back to the native HTML for any reason, then that list item becomes important. So what happens if we apply all of those ARIA roles, but we don't do anything about this keyboard interaction that we need to provide?
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element.
Well, it's fantastic. We've got the first tab. We know what that says. But that's all we're getting. There is no ability to move between the different tabs. There's no ability to move off this tab and into the tab panel contents to read what that says, because the tab list role has stripped the screen reader of all the usual commands that someone would use to get at that information. So we've effectively broken this interaction completely for someone using a screen reader. So what do we need to do in terms of providing that interaction? Well, one thing we need to do is something called a roving tab index. What we basically want a screen reader user to be able to do is to hit the tab key, move focus onto the first of the tabs, the one that's currently selected, and if they don't want to stop and interact with this set of tabs and tab panels, we just want them to be able to hit the tab key again and just bounce straight off it, onto the next thing. We don't want them to have to hit a tab key every time to hit each of the tabs and then all the content. That becomes really hard work. So we need to make the set of tabs just a single tab stop. And you're not the only ones. I get tangled up with the tab as a key versus tab as a thing we want to interact with. So what we do is that the currently selected tab has either a tab index of 0, or in this case, because we've started with an anchor element, it's focusable anyway. We don't need to do anything. But we take all of the other tabs out of the keyboard sequence completely with tab index -1. So that means now it's impossible for a screen reader user or any other keyboard user to tab onto the second tab in this example. And that's OK in this particular use case. Think very carefully if you want to use tab index -1 in any other circumstances. You've really got to want to be sure that you don't want a keyboard user to get to something if you use that tab index value. So again, it's not that you shouldn't use it, but just think very carefully about whether you should or not. What we do then is we enable JavaScript to handle the roving tab index. So what happens is if someone hits keys to move left and right through the set of tab panels, we update those tab index values. We move focus using the setFocus method, and we just handle focus like that. And we need to listen out for the arrow keys in order to engage that particular interaction. So if someone hits the left or right or up or down arrows, they should be able to cycle between the set of tabs. We use the focus method to move the keyboard focus to the one that is currently selected. That brings it into view visually and triggers off all the expected behavior of a set of tab panels. And so this is how it works out in practice.
Tab, blanco tab selected, use JAWS key plus Alt plus M to move to controlled element. Reposado tab selected, use JAWS key plus Alt plus M to move to controlled element. Joven tab selected, use JAWS key plus Alt plus M to move to controlled element.
So now with that keyboard interaction with the JavaScript, with the ARIA, we've got something that looks like a set of tab panels, behaves like a set of tab panels, whether you're using a screen reader or just a keyboard or any other particular assistive technology. So it's really important when you use these roles to provide all the interaction that the browser would have done otherwise had something like a set of tab panels existed natively in the browser in the first place. I mentioned earlier that the platform accessibility APIs that people use are not JavaScript APIs. There is work starting to happen on something called the accessibility object model. It has people from Google, from Mozilla, and Apple working on it. And if it comes to fruition, which I hope it will be a JavaScript API for accessibility. And it will have 4 phases of development. This is what they're proposing to work on. In the first phase, it will be possible to modify information that's in the accessibility tree in the browser. So maybe provide a little extra accessible description or a better accessible name, just to modify the information that the browser exposes. In other stages after that, what they hope to be able to do is allow you to add virtual nodes into the accessibility tree. So if there is something available in the DOM that for some reason is not being translated through into the accessibility tree, you'll be able to do it with JavaScript instead. And ultimately, they want to bring this particular API to the point where, as developers, we can actually query the entirety of the accessibility tree ourselves and make use of the information that right now is only available to assistive technologies. It's an incredibly exciting and, in some ways, scary piece of technology and research that's being developed here. Because if we thought it was possible to blow the car up with JavaScript and ARIA as we have them now, the capability we will have will be practically nuclear in terms of causing problems. But on the other hand, it puts a lot of accessibility and a lot of what happens under the hood out of sight in terms of accessibility into the hands of developers. And actually, I think it's safe to say that as developers, we're pretty okay with getting our heads around some of the complicated stuff and making it work when we have to. So I think it's one to watch and definitely an exciting future for accessibility in the browser. So just remember that you have great power as developers. JavaScript and ARIA in particular can do enormous good for accessibility, but equally try to use them in just the right way to blow the doors off and not the entire car. Thank you very much.
Any questions?
Hi, great talk, by the way.
Thank you.
Is there a standardized way to communicate keyboard shortcuts to screen readers? Because I always add keyboard shortcuts to everything I make, but I'm not sure how to communicate those to screen reader users. I know that some apps use the question mark, but is that enough of a convention?
So do you mean, is there a standard set of shortcuts to provide, or is there a way that will kind of work for all screen readers?
If there is a way to communicate to screen reader users what these shortcuts are, which shortcuts are available.
So there is one way to make the shortcuts work for all screen readers, but you're going to hate me when I say this. It's the access key.
Oh, yeah.
Which is why I don't advocate it right now as the solution. In terms of an actual standard set of the shortcuts to provide, I don't believe there is. I think the question mark is pretty standard as the way to show which shortcuts are available. Mm-hmm. But in terms of actually the shortcuts themselves, I don't believe there is. But I use a Windows screen reader, so perhaps I'm not the best person to know which ones are available. I think a lot of the JavaScript shortcuts are actually very application dependent. So the ones, say, in Gmail are very focused on getting around and doing email things, whereas you know, the Twitter ones, for example, or the Facebook ones have a very different set of tasks that they're there to accomplish. So perhaps not.
Thank you. I was actually asking about the question mark, like if that's standardized enough. Like, I assume that the keyboard shortcuts are there. I've already implemented them. I've chosen a good set of shortcuts. I'm not asking about which shortcuts to choose. Just how do I tell a screen reader user what the shortcuts are?
I see what you mean. So Twitter does it by showing so the dialogue that was in the screenshot that I showed first of all. That's permanently visible to screen reader users. It's not visible on the page for everybody else. So when I first go to the Twitter site, I get that dialogue. There is a close button that lets me dismiss it once I've had a look, but that's how they do it, is that they display it to screen readers, not visually.
All right, thank you very much.
So I had a question about the accessibility object model. You had 4 phases there, and the last one I was surprised to see was querying the accessibility object model. And it seems to me that if I was doing that, the first thing I'd do allow you to query it, and then secondly, allow you to modify bits.
Yeah.
But how can you modify it if you don't know what's there?
That's a very good question, and I think probably a fair one to pose to the team that's working on it, because the thought did occur to me as well that, yep, just extracting information would seem like a first step. And then, yeah, changing that information or adding to it. Yeah.
Cool, thanks.
I have a question for a difference. Is there any way that we can see how many of our visitors on our website use screen readers? I mean, if I want to convince my boss to spend time on this, do I have some numbers?
Not really, no. If you develop native iOS apps, you can tell whether somebody has the screen reader enabled in a native app on that platform, but in terms of the web, no, not really. Over the years, people have suggested a few ways it might be possible. There's actually an ongoing and fairly raging argument over whether that's actually a good thing to do or not, though. On the one hand, using it as a positive to encourage people to recognize that that audience exists seems like a really good thing. But on the other hand, it's asking the person using the website to reveal something that's very personal about them, more so perhaps than their location or the language that they're reading the website in. This actually speaks to a very personal characteristic. And I'm not sure myself yet whether the web is at the point where it can collectively be trusted with that information. We've also got the other problem. It takes us back a bit to the days where we used to do browser header sniffing. And we used to say, if someone's using Internet Explorer, do this. If they're using Firefox, do that. And we pretty much abandoned that as a bad idea in favor of feature sniffing because it's much more fine detailed. And we've got the same problem. You can detect that someone, or if you could detect that someone was using a screen reader, that's all we'd know. You wouldn't know if they were using a screen reader because, like me, they can't see anything, because they are partially sighted and they're having a bad day, so they prefer to listen, not magnify, because they've got autism or dyslexia, and actually it's easier to read or listen to content rather than actually interact with it, using their eyes and a mouse, but they're still a sighted person. So even if we know someone's using a screen reader, it's a bit like knowing they use a browser. We still don't really know, why or what that person's using it for. So we're kind of in danger of repeating history a little bit there until we can figure it out a bit more, I think.
Okay, thank you. And I have another question too.
Sure.
Given that we are in Greece and English is not the primary language here, what's the state of screen readers in non-English languages?
Pretty much the same, actually. All of the screen readers that I mentioned before support VoiceOver on a Mac will support any language that a Mac supports. It's the same on iOS. Narrator on Windows 10 is the same, I believe. So whatever the language of your operating system, Narrator will support that. JAWS and NVDA both support many languages. I think with NVDA it's about 40 different languages. JAWS 30, 40 maybe. It's been a long time since I've looked, but they're extremely multilingual, so people use these technologies all over the world in many, many different languages.
Okay, thank you. You have some other?
Hello.
Hey.
Thanks for the great talk. I have a question regarding screen readers and how they interact with rich web application with a lot of JavaScript. And what I want to explain is that there are a lot of cases when I'm trying to test my application. For example, I usually do with JAWS and NVDA, and there are a lot of cases that they don't. I don't have the same behavior. The same. They don't. Probably sometimes they don't understand the interactions that I did with the browser in the same way. The thing that you said probably that they consume maybe the keyboard events that I'm doing. So sometimes they translate in a different way. And which is the best way for me as a developer to make them behave in the same way? I have spent a lot of time on this thing.
Yeah, I actually wouldn't try. Believe it or not. So I'm going to give away my age to some extent here. I remember the days when we used to have a lot of pain making stuff look the same in two different browsers. You know, I work for an agency and a client would say, but that logo's 6 pixels off in Internet Explorer, but it looks great in another browser. And it took us a long time as an industry to get used to the idea that actually the things didn't need to look identical in two browsers. They just had to look good in both browsers. And it's kind of the same with that with screen readers. They all do things a little bit differently because there's no specification that describes to them how they should behave. So don't think about it in terms of, you know, JAWS says this, NVDA doesn't, or NVDA does that, but JAWS sort of does it, but not quite the same way. Ask yourself, can someone who uses those screen readers do the job they need to do? And if the answer to that is yes, then you're pretty much all the way there. Don't worry about comparing them too much.
Thank you very much.
Do we have another question? Oh, yes, we do.
Hi, Léonie.
Hey.
I was wondering, what's the situation these days regarding the redundant ARIA roles? There was a time when if we wanted to use the main element, and that wasn't being broadcast yet to the screen readers, we'd use main equals, so it's like main role equals main. Do we still need to be doing that?
Only if your target audience still includes Internet Explorer users. It does. I'm sorry to say, we sadly still live in a world where you know, there are a number of them out there, and so one of the projects I work on is the UK government's website, and we've still got an enormous chunk of Internet Explorer users out there. So we do duplicate it. So where we have the main element, we have role equals main. If you don't sort of have too many IE users in your audience still, then you're fine. You don't need to use them at all. And actually, the W3C conformance checker, if you check your code, will encourage you not to use them. So that's the exception.
Hi, I have a question regarding headings and semantics. We had a discussion in the Slack channel a while ago, in the accessibility one, that Drupal uses a lot of element invisible classes on headings, like H2s, for example, above the search box or above every menu that you use. One of my clients asked me to remove those headings since his search engine optimization club told him that that all these headings made a lower score on Google. So I did some research and I had some debates with several people, but no one really knew if that was true, the point of the search engine club.
It's not true. My colleague Steve Faulkner, who's one of the editors of the HTML spec, looked into this about 2 or 3 months ago because one of our clients at the company I work now, the Paciello Group, had asked exactly the same question. And he went and found somebody on the Google search team. And if you tweet me or find me afterwards, I can send you the link. But he responded on an open forum to say, no, yes, Google's please. Smart enough as a search engine to recognize when it's a little piece of text that's actually being used for something useful, as opposed to just, you know, SEO hacking. So
good, thank you.
Another question? So no, we're done. Thank you very much, Léonie. Thank you very much for helping us making web accessible.
Thanks very much.